the light which we observe or which is present nearby us is non-polarized light or unpolarized light. What is the meaning of this? What do you understand by non-polarized light or by unpolarized light? So, the light whose vibrations or the waves, the light waves vibrations are in each and every direction are known as unpolarized or non-polarized light. Okay? But here we have to understand that what is a plain polarized light. So, the plain polarized light are the light or the waves in which all the waves generally moves in a single direction. That means the vibrations occurs in a single plane. It is known as plain polarized light. Now, the process of transforming such kind of non-polarized light or unpolarized light to the polarized or plain polarized light is known as polarization. And the material which is used to convert such kind of non-polarized light or unpolarized light to the polarized one is known as polarizer. Here, polarizers can be prism, it can be a grating, right? All this can be used to convert a non-polarized unpolarized light to the plain polarized light. Let's understand it through the image. Here in the image, as you can see, we have unpolarized light. Now as you can see it here, unpolarized lights waves are or the vibrations are in each and every plane, right? The vibrations are in almost each direction. So it is present in each and every plane. Now when it is passed through the polarizer, as you can see it in the image, all other vibrations are absorbed there, are stopped there, and a plain polarized light is allowed to pass through it. So we get the light which contains the waves whose vibrations are present in a single plane. Right? Such kind of light is known as polarized light or plain polarized light. Depending upon it vibrates in a single plane. So plain polarized light. Likewise. Now let's move on to the next point, and which is plane of symmetry and chirality or chiral carbon. These two are the terms which we need to understand before we will study our compounds or optical compounds. So the first one is plane of symmetry. The name itself suggests a plane which divides the object into two symmetrical parts. Understood it properly. The plane which divides our substance or compound into two symmetrical parts is known as plane of symmetry. The plane which divides it into symmetrical parts. That means plane of symmetry. Simple. Now let's move on to the next term, which is chiral or the phenomenon, which is chirality. So we have a carbon atom. We have seen till now many organic compounds which contains carbon get attaches with other functional groups or other atoms here. But here as you can see we have a carbon atom that has 4 different substituents group or atoms is known as chiral carbon. Carbon contains each and every different group. All the 4 valences are fulfilled by different group or by different atom is known as chiral carbon. Okay. It is denoted by star. C star. It shows that this is a carbon which has every atom that attaches with it is a different one, totally different one. Such kind of compounds are optical active compounds actually, right? Now, let's understand it with the help of an example. So, we have a carbon here, right? As you can see it here, a chiral center can be seen. On the upper side it has H, on the left side it has CH3, in our direction it contains Br, other direction contains OH. So, 4 different groups are present, H, OH, Br and CH3. All the 4 groups, all the 4 molecules or all the 4 atoms are different. So, such kind of carbon is known as chiral carbon. Now, such kind of phenomenon is known as chirality. Okay. Now, here you can see that they are non-superimposable on each other, but they are mirror images of each other. So, in that manner, we can say that they are optically active compounds. Each and every chiral carbon is always an optical active compound. Okay? Let's move on to the further one, which is measurement of the optical activity by polarimeter. Here we have one instrument whose name is polarimeter. Now, what is the meaning of it? Right? We have to understand that we have till now seen that what is actually optical activity, but how we can measure it. So, for the measurement, we use an instrument. So, the instrument which is used to measure the optical activity in any compound is known as polarimeter or polarizer. Okay? When light is passed through a polarizer, whether it's a Nicol prism, it's a grating, etc., only light oscillating in a single plane will leave the polarizer. Otherwise, all the different plane or all the other light whose waves are vibrating in different planes will be stopped at that particular point, and only the single vibrating waves light will be passed through it. So, it's the principle of polarimeter. Okay. Now, let's understand how it proceeds and what is the working of it. So, here as we can see, we have a high intensity light bulb. The first one is a source, light source. So, a high intensity light bulb produces unpolarized light or non-linear polarized light. Okay. After that, it is passed through the polarizer. It can be Nicol prism, it can be grating, etc. After passing through it, the next step, it converts itself into plane polarized light. This plane polarized light will be allowed to pass through a cell, which is known as polarimetry cell or a sample cell, which contains our sample. Now, if the sample is optically active, if it's a dextroform, then it will rotate the plane polarized light towards right hand side. If it a levo one, then it will rotate it to the left hand side, and if it is a racemic one, then the plane remains unchanged. That means the angle remains unchanged, so that we can observe it through the analyzer, even that the plane will not be changed, or what is the change we have observed. Right? In this manner, we can separate the form of any kind of optical isomers. Right? Here, as we have seen, we have 3 different forms. If the compound rotates the plane of polarized light towards right or in a clockwise direction, then it's a dextro, denoted by plus sign, written as D plus. If the compound rotates the plane of polarized light towards left hand side or anti-clockwise direction, then it is known as levorotatory, denoted by L minus. And if the compound is a racemic, totally neutral, then no change will be observed in the angle of plane polarized light. So it is denoted as optically inactive. active compound. Okay, in this manner we can separate any kind of optical isomer. Now let's observe optical activity in lactic acid. This is the structure of lactic acid. C star contains one active carbon, one chiral carbon is there. After that, now here lactic acid has two structures. They are mirror images of each other but non-superimposable. So we have here totally D-lactic acid and lactic acid. They are non-superimposable to each other but mirror images of each other, as you can see. The upper side contains OH, the lower side contains CH3. Left and right, H and C double O, just the position of it is changed. Now, next one is, which three forms are there? So first one is D plus, right? So dextrorotatory lactic acid. It is also known as sarcolactic acid. After that we have L minus lactic acid, that is LEVO, obtained from fermentation. Third one is racemic. It's a mixture of both, right? Doesn't create any change. Now, next one we will have is optical activity in tartaric acid. The structure is given in the image. It has four different forms: D plus, L minus, racemic and meso. Let's see that how that form actually changes. So as you can see it in the image, we have D plus lactic acid and L minus tartaric acid, right? Both are the tartaric acid, non-superimposable to each other but mirror images of each other. Just the position of the upper carbons, right? Which is basically, see the position of H and OH is just only change here. So that is the D plus and L minus forms. Now next is meso. Upper half and lower half of that particular compound remains same. And last one is racemic mixture. This is totally optically inactive, as we can see it here. Okay. Thank you everyone.